so let's get started. First of all, I would like to thank you all for making it to this session. I understand that you had a choice of very good sessions, and I appreciate you coming out here. So we have had a lot of fun since this morning, right from when Brad Anderson entered on the stage on his Aston Martin. That was probably a dramatic entrance, and I had not seen anything like that since the London Olympics opening ceremony. And post that, there were a whole lot of keynote demos. And post that, depending on which foundational session you went to, the Brian or Scott or Jeff, they showed a lot of new stuff with demos as well. So it has been an exciting day so far. And I don't want this momentum to die down post-lunch. So I want this session to be an interactive one, and I want to see lots of energy. So what we are going to do in order to make that happen is this. I am going to ask you a bunch of really simple questions to start off with. And if the answer is yes, I don't want to show off hands because that feels like a classroom and I don't like that. But instead of raising your hands, you clap like that, right? So the more the noise, the louder it is, the more the yes. All right? So let's start with some simple ones. Are you having a lot of fun? Come on, the Surface RT at $100. That has to be fun. Do you think performance and load testing is important for your or your customers' applications? Do you think load testing today is super easy to do? Well, you're in the right session then. And by the way, keep continuing that applause throughout the session. I absolutely don't mind that. Okay? So just to introduce myself, I am Darshan Desai. I work as a lead program manager in the India Development Center out of Hyderabad in India, in Microsoft. So I've been with Microsoft for the last 8 years, and the last 6 years I've spent in the Visual Studio ALM team. I've been working on various different features such as lab management, testing. I've touched the breadth of ALM. And for the last year and a half, my team has been working on I have been the product owner of web and load testing as part of Visual Studio, and our team has been working on the load testing service, which I am here to talk about. Before we get started, and I talk about how this session is going to be structured, I want to talk about some of the top challenges, the top 3 challenges, if you will, for load testing today, right? And if you agree, and this is what we have heard from some of the customers we have talked to, as well as from our own internal teams, because we host a lot of web services and websites out there when we do our load testing. If you agree with these challenges, you know what to do. Firstly, provisioning or setting up machines. Load testing is an exercise which requires hardware, and provisioning this requires budget approvals, getting this whole machine, setting them up, configuring them, maintaining them. This whole process is painful and slow. Do you agree? The cost of persistent hardware, both the capital expenditure as well as the cost spent in maintaining it, is actually very high. And load testing is not an activity which you do on a daily basis. Hence, it doesn't make sense to buy that hardware and keep it around if you're not using it. Would you agree with that? And the final one is, if your app is hosted in the cloud, for example, you have an app hosted on Azure, doing load testing on that particular app or website has its own set of challenges, such as, hey, you're throttled by the bandwidth or the firewall restrictions of your corpnet. The latencies are unpredictable when you try to do load testing on premises, and so on. So you need a cloud-based solution in order to do a load test, an Azure-based app. Do you agree with that? Can you say that again, sir?
You only have so many compute hours, and you don't want to chew through all of them through load testing?
With the MSDN subscription, you mean? Yeah, but we'll talk about pricing and how you could pay more and do more load testing as the session progresses. Okay, so what we'll do is, at the end of the session, we'll come back to these 3 challenges and revisit and see whether we have solved some of these. Because when we started building a service to do load testing, these were the challenges we were trying to solve. Okay, so today we're going to start the first section. I'm going to spend some time looking at load testing with Visual Studio. This is not something that's entirely new, but this is web performance and load testing as you do it with Visual Studio. Some of these capabilities existed since Visual Studio 2005, 2010, and in 2012 as well. Going to just spend, some of you might be more familiar with it than the others. I want to just spend 10 minutes to refresh this and talk about what we have already got. In the next section, we'll see how to take advantage of the cloud in order to run the same load tests that you have on premises today on the cloud, right? And how to scale up seamlessly. And in the final section, I want to do a little bit of a deep dive on the architecture of how the entire load testing service is built. Who are some of our early adopters? What are some of the items which are top of our backlog, next steps? And definitely I want to keep good amount of time for Q&A because I'm sure you would have many questions. A bit about the demos, and I know at TechEd, you love to see demos more than slides. So I promise you that majority of my time, at least 2/3 of it, is going to be focused on demos. And the other part is, what I'll do is I have a app, a music store app, an online music store app, which I have hosted on Azure. And that is all that I have. I have no tests pre-created or any of that. I'm going to start off from a clean Visual Studio, create the entire set of tests, run them right in front of you so that there's no magic that happens behind the scenes, and then you could know how you could go and do the exact same thing for your app as well. All right then, let's get started. The first section I'm going to talk about load testing with Visual Studio, the basics and what exists, what you can do today, what you can do with 2010 and 2012 versions. Before we get into the demo, there are a lot of these terms associated with load testing. I want to be sure that all of us are on the same page with respect to those. Let me spend a minute on each one of them. So I have this music store application that I've hosted online. I'm done with my coding, my unit testing, and stuff like that. But before I put it out in front of any customers, I want to really validate the performance, the scalability, and the reliability, these essential metrics of my application to make sure that, hey, it is responsive enough and it is reliable enough. And that is what I call performance testing. So once I've done my performance testing and I've deployed my app out there, hey, now thousands of users are going to access it when I make it public. And will it hold up or will it just crash? So I want to do it I want to simulate the same performance testing with real world volumes, under a real world load. And that is what I call load testing. Well, now I'm sure that, hey, I find and fix problems at each stage, right? So now I know that it can hold up this load, but what is my ultimate failure point, right? When will my app just fall apart? So I keep on increasing the load until the app breaks, and that is what I call stress testing. And this is in order to figure out, hey, where is the real bottleneck? Is it in the data access layer? Is it in the web layer? Is it in the cache? To figure that and fix that. And finally, there are some business questions that I need to answer. For example, my business team has decided that, hey, next year we are going global, and this will increase my capacity by tenfold. Are we set up to do that? Or what is the kind of budget that we need to keep? What is the kind of capacity that we need to procure in order to do that? And I do this test specifically to determine my scale or capacity to answer these business questions. That is what I call capacity scale testing. And so these are the different kinds of tests that you run. And overall, we call this as performance and load testing. But these are the various kinds of tests that you could do. And Visual Studio lets you do all of these, right? There are other terms as well, such as limit testing, endurance testing, and so on. But broadly, these are the 4 categories or scenarios of why you would like to run load tests. All right? So in my demo, actually, I will walk you through each one of these categories and show you how to do them, how to do performance testing, load testing, and stress testing. Okay? So without wasting further time, let's get started with the demo. All right, so here I have my Visual Studio. As promised, it's clean. This is a Visual Studio 2013 preview, an early internal build that is installed on my laptop. And let me go here and say File, New Project. And I choose a web performance and load test project. That creates a project for me. The first thing I'm going to need is to record a set of web performance tests. These tests, web tests, are the ones which record all your requests and responses and let you measure the performance of an application. So let me go ahead and start recording. When I say add recording, it launched IE for me, and it brought up a recorder add-on right here. And here is my app. As I told you, it's a music store app. It's deployed on Azure. This is the app that I've already deployed, and I'm going to use this for my demos. It's called Demo Music Store. And here is the recorder. This is the web test recorder, which keeps on recording all my actions, and I could go modify them if I wanted to. So the first scenario I want to record is there are different categories of users who come to my site, but the most common category of users just come and browse for music. They don't buy anything. They just come, they browse, and they go away. Right? So that's the first test I want to record here. So let me go to a couple of these albums. I just browse, I look at the details, and that's about it. So when I click stop, what Visual Studio is automatically doing is it's trying to detect if there are any dynamic parameters in my requests. That is, an example of that would be site ID, which is supplied as a response, supplied as part of the response in the previous request, and that is reused. If there were any dynamic parameters, it would automatically parameterize them so that your test would not break each time you replay it. And once that process is complete, here I have my web test with all the requests which I recorded, and this is ready to go. Let me go ahead, run that web test. As I run the web test here, and this is all on my local box so far, this is on my local client, I can see that, hey, the test is being replayed against my site, and here the time it took to render a response, as well as all the dependent sites, how long each resource took to load, all of that is given to you, right? So this is the first step out of those 4, which is performance testing. Now I know, you know what, 3.7 seconds, it looks a little slow. Yeah, this one is under a second. That looks fast enough. And I can make some conclusions out of this. And at the same time, I could go ahead, look at the entire request response. I could do a bunch of stuff, such as I can parameterize some things, add more extra validation rules, and so on. Right? So one of the things that I would like to do is I would like to parameterize this web test so that, hey, I have recorded this against demomusicstore.cloudapp.net, but what if I want to test it out against a different URL on a different environment? So that I can very easily do that with just one click. And it asks me if you want to parameterize the web server. I say yes, and the web server is there as a parameter. And if you notice here, all the requests have the parameter here, and the value will be filled up at runtime. So this way, my test can now run across multiple sites as long as I just change this one parameter over here. Right? So the other thing I want to do is I want to rename this test with a friendlier name. I recorded my browse scenario, and I would call it browse.webtest. And I'm done with my web test. My first test is recorded. Let me go ahead and create another web test. And this time, I want to record the add to cart scenario. Just to make it a little realistic, I want to have a mix of 2 tests. So let me go here, add this album to cart, go here, pick another album, right? And that's it. And as you can see, there would be many more such combinations. For example, checkout could be another scenario, and so on, which you could record. I'll just use 2 for my demo. It's doing detecting the dynamic parameters again. And what I'll show you next is, I think it's done. So let me rename this test, call it add to cart, and parameterize the web servers for web server for this one as well. So this is a parameterized way in which you can see all the requests, and it's actually stored as an XML in the background. Now, you could do some stuff here, like you could add some plugins, you could add some conditional statements and things like that. But what if you're more comfortable with code and you want to see this test in C# code? And that's very simple to do as well. There is a generate code button out here, and if I click on this entire test will be converted into a coded web test. And as you can see, this test is now all in C#. So it's the same test, the set of requests and responses that we have there. And if you notice here, we have the web server parameterization also called out here. You could go and do some advanced loops and data binding and stuff like that if you're more comfortable with code and you want to maintain this kind of test. So both coded tests as well as the regular parameterized tests are supported, right? So now that I have created all my tests, web tests that are required, this is how I do my performance test and look at the response time with one user from a local machine. Let me now go ahead and create a load test, because now I want to simulate some real-world load. What if there are thousands of users who are accessing my site, and I want to measure the performance characteristics in that condition? And in order to do that, let me go ahead say I want to create a load test. So say add load test. This brings up a wizard. And I could go ahead and define a scenario. And in this case, my scenario is a non-paying user scenario who just does a browse add to cart but never checks out. You could have multiple such scenarios as well. And as you can see, there are some settings around how do you want to do think times. These are the times between each request. This next step you want to decide is whether you want to have a constant load pattern, that is, I would have 200 concurrent users at any point of time, or do you want to do a step load pattern, which is ramp up my user load in steps of 10 and reach to a maximum of 200. In this case, just to make sure my site behaves fine, let me go ahead with a constant load pattern and select 200 concurrent virtual users. Notice that this is 200 concurrent virtual users, not a total of 200 users. So if you had, say, 10,000 users accessing your site for a matter of 4 hours, then probably there would be 200 concurrent users at any point of time, and this would be enough to simulate that. The next, I have a few more settings on how I want to distribute the tests. Let me select the default here, and it asks me what test do I want to add. So I have these 3 tests that are recorded: browse, add to cart, and add to cart coded test. I'll add all of them. As you can see, within a load test, you can run a web performance test, which we just recorded, or a coded web test, or a unit test as well. If I had my unit test which the developer had written, I could run them against my WCF, against my service endpoint as well from here. And it lets me pick the distribution. I think there are a lot more users. I think 70% of my users are going to do the browse scenario, so I'll dial it up to 70. And maybe 20% of users do this add to cart scenario, and just 10% of users do the other one. All right, so I can actually model my scenario in such a way that it behaves, it simulates real user behavior. I can go ahead and pick various type of networks as well to simulate. 100%, by default, 100% of my users are simulated to come from LAN, but I could go and say, you know what, I want 50% of my users to come from LAN, 30% from Wi-Fi, 20% from 3G, and there is a network emulator out there which will actually throttle the network bandwidth for those requests so that you can actually measure response time for various categories of users as well, various categories of networks. And then there is browser mix. I could go ahead and add Chrome and Firefox and say, you know what, I think 60% of my users come from Internet Explorer, and the rest come from Chrome and Firefox. So go ahead, add those to the browser headers and simulate that behavior as well. As you can see, there are a lot of parameters and settings which you could actually go to simulate a real-world load pattern. And finally, you specify the test duration. You could have a little warm-up duration so that you don't run into a spike at the beginning because of a cold start of your service. For now, I'm just going to pick 1 minute as my duration because I'm just going to test it out to make sure it works fine and say finish. When I do that, my load test is created for me with all of these settings, and I could go modify them at any point of time. Right? These are my scenarios which I have added here, and here is my browser mix, here is my network mix, and my load pattern is constant load pattern. Right? So let me just go ahead and run this test. And right now I'm running it locally on this box to test it out, which brings up this UI, which lets me track the progress of my test. So I can track some key indicators such as user load, pages per second, and stuff like that, page response time, and how the performance of my local machine, my controller and agents are going on, and all of that stuff as the test is in progress. So right now I'm running this test on a local machine. I could go and run it remotely as well on premises. And this functionality also existed in the older versions of Visual Studio. In order to do that, I could go here, say manage test controllers. I need to set up different machines which form my load testing environment and deploy Visual Studio test agents on them. And once I have the agents set up, I hook all the agents up with a controller and specify the controllers and agents here, and then I could target this exact same load test to run on that as well. And this is how we scale out. And this is all available in the on-premises version. So after this load test ends, let me show you how we could actually, as you can see, while the test is in progress, you can see that there are a few threshold violations. You could go review them. And here it says, your network interface, the number of, because I'm running this all on my local machine, and your network interface, right? And here is my total bytes. It actually violated the threshold that was set by default for the traffic that can go out. My test is now complete, and I get to see a summary. If I had multiple pages, I can see on the right here, I can see the slowest pages and which ones should I really focus my time on. And then I can see the overall results here, which tells me my requests per second, which is my throughput, and then my average pages per second, and response time, and all the other details. I can go and look at the graphs. I can add multiple counters from here. I can drag and drop any of these counters on the graphs and get that view. I can zoom into these graphs. I can get multiple views here if I want to really zoom in like that. Right? And I could go look at all the errors and threshold violations, and I could even go and look at the details, which is at each moment, what was every virtual user doing. So there's a lot of detailed analysis that you could do post a load run, which is actually the purpose of the load test, to find and fix performance bottlenecks. So the other thing I wanted to show you real quick was create Excel report. Once you have this load test run here, what you can actually go and do is you can create a trend. Right? I have run this load test multiple times. And I have run this test like 5 times now. And when I say finish, it generates this trend of how my application performance has changed over the various builds or over the various load runs that I've done. And this way, when I publish it, it is very apparent to see where there were regressions and where the performance metrics haven't changed. Right? So these are the graphs of various different parameters over the different builds. As you can see, there was pages per second went up, but then it dipped down, came down again. Same thing with requests per second. That clearly indicates that there is some problem here, that the RPS became low, right? And that's something that we need to investigate and stuff like that. So this was a quick walkthrough, and this ends my first demo. This was a quick walkthrough of how we can actually do performance and load testing. You saw both the scenarios of performance testing and load testing under real-world conditions using Visual Studio. So what did we see here? The first step, which is kind of a prerequisite, which I didn't show it to you in this demo, is configuring the test environment. That is, hey, you figure out how many machines would you need to simulate this load, and install test agents on those machines. Right? Hook it up with a test controller. Post that, we saw how we could go author tests, create this web performance tests, as well as author this load tests, run these tests using Visual Studio. I showed you how to run it locally, the exact same way you could run it and target it to a controller as well. How you analyze results, you can do the analysis within Visual Studio itself, create these trend reports with Excel and so on. And finally, how some of these results with the trends and with the key counters that we give help you spot, find, and fix performance problems. So this ends the first section, which was about, hey, what was there in Visual Studio 2010 and 2012 for web and load testing. And in the next section, we enter into the cloud-powered load testing of how we take this onto the cloud and extend the capabilities there. Before that, are there any questions somebody had at the beginning, top of your mind? Yes, sir. The question is we saw a browser mix and a network mix. Is there an operating system mix? That's a good question. The thing there is the web tests that we saw operate at a HTTP layer. So the operating system really doesn't matter. These are web requests that we were recording and replaying. So what we are trying to simulate is different kinds of web requests and for which actually network, browser were the things that mattered. The operating system, really not so much.
That shows the testing from the users hitting your website. What do you recommend for getting the metrics as code running on your servers so you can see what's happening while the unit test or load testing is happening?
Oh, what about getting performance counters from your server under test? That's a great question. So the question is, hey, you showed the metrics from user side. How about from the server itself? So let me show you this. If I go back to my load test here, on premise here, and say, let me open up. I skipped over this step. So essentially, if this is your server under test, you could add this server, and you could add what counters need to be collected from here. And while your load test is in progress, your Visual Studio or your test controller connects to this server, pulls down all those counters for you. And you could see, as you can see, there are not just the system counters, it is ASP.NET, IIS, SQL, all other SharePoint counters as well. So you could get all of this so that when you see the report, you can see these counters correlated along with your client-side counters. Okay? All right, so let's move to the next section. So what's really different here? Right? Let me straight away, I need not have switched. Let me straight away go back into the demo here. This is a test. This is the same test that I ran on my local machine, which I can run on premises. Let me just show you how to go ahead and run the same test on the cloud. Right? And all I need to do is this something called test settings here, which decides which is where you configure what you want to do as part of the test. There are a lot of tabs over here. All you need to do is one setting, which says run these tests using Visual Studio Team Foundation service. Right? Instead of running them from a local computer or a test controller, run them using the service, and that's it. As you can see, all of the other settings which related to how should I set up the machines, what should be the roles, and all of that stuff just went away. The options available for you are, hey, do you want to deploy something before your test runs? And there are a few customers who do this. It's like to deploy, if your app requires a client-side certificate to be installed, or you have a unit test, you want your DLL, some of your other DLLs to be dropped, on which you have a dependency on, and things like that. Do you want a setup and a cleanup script to be run before the test? And an additional setting, which again applies to unit tests, which is, hey, do you want the test to be forced to be run in 32 bits? And all of these are optional. So essentially, I just chose this one setting, which says run tests on your Team Foundation service, and I hit close, and then I go ahead, hit the run button. And that's it. Now what's happening is the test is getting uploaded onto the service. From Visual Studio, I am connected to my Team Foundation service project here. Right, and that's all that is needed. You don't have to provide any extra credentials or any kind of extra account names or agents and stuff like that. All of that is automatically taken care of for you. So the current step is it's configuring agents, and what's happening at this stage is the service has received this request, it has accepted this test, and at this point, the agents are being set up with your test, as in the test binaries are being uploaded onto those agent machines, and momentarily the test would start running. Actually, the test is already running now. This is the same load test that you authored on-prem, which is now running on the Team Foundation service on the cloud, and you can see we are seeing some live counters come down as well. Right? This is just a 1-minute test, and we have 2 graphs for you, which show you the key counters while your test is in progress. And while this test is in progress, let me show you one other thing that we have. So once you complete this test, how do you really go back to them and review all the tests that you did or somebody from your team did? So we have built this thing called Load Test Manager. You go here, Load Test menu, Load Test Manager, and this gives you a list of all the tests, all the load tests that have been run against the service. I change the date filter. You could filter by state, date. And for those of you who have used the service, this looks familiar to the Team Foundation web UI. Actually, this is all based out of Visual Studio. It has the same look and feel. It's It's all built in HTML and JavaScript hosted within Visual Studio. As you can see, this gives me a view of all the tests that have happened in the past. I could go review the results of some of them if I wanted to. And it tells me what time were they started, what were the names of these tests, what was the duration of these tests, and who requested it. I see that there's one ID which is done by somebody else, and that is another of my team member who actually ran that test, so I can get a single view of all the tests that have been run on my account. Well, now as we can see here, I'm going back to my test which I was running. It is completed, and once the test is completed, the results will be actually backed up. They'll be archived, and once that step is complete, we will see a link here to download report, and that's what it currently says. It's collecting all the results from the test, and once that is complete, we'll see a report right here. And when I say download report, it downloads the archived report of this particular test on my machine. And when I say view, I can get the full rich view of my test run. This is the exact same view that you would have on premises to do the in-depth analysis, do the Excel-based reporting, and to do all of the stuff that I showed you before, right? So you could do all of that reporting for your tests that are running on the service as well. So it was the same tests that ran on the service. It was a similar kind of reporting and analysis that you could do for those tests. There was absolutely no change. All you had to do was one setting here in your test settings that says, run tests on my Team Foundation service. It's actually as simple as that. Okay, so while I am looking at my tests, I notice that, hey, there is a problem with my requests per second. And look at the value of requests per second with this user load. It is 19.27. The average is around 20. That seems to be a little low to me based on my tests that I've done in the past. Right? So that's a problem. That's a potential problem in my app under test. And now, how do I fix it, and how do I verify that the problem is actually fixed? In order to do that, now that I've identified the problem, here is the code for my application under test. The developer does some debugging of why the RPS is low and figures out that, hey, there is actually a problem, that there was an if-def statement here, and then there was this conditional field called use cache, and if that was used, it would actually go hit the cache. If not, for each and every request, it would actually do a database lookup, which actually slows down the app significantly. And if you look at it here, hey, somebody, when they checked in the code, they did not set this flag. This was meant to be tested and not to be there in the final build, but somebody forgot to do that. So here is a problem. We have identified the problem here, and so we can go ahead, fix the problem. I just need to put this symbol here, use cache, and the moment I do that and I do the build, you can see now my application will start hitting the cache, and the else statement is grayed out, right? So the problem is fixed. I'm not going to waste time here by deploying this app again on Azure. So what my developer has done is he has fixed this problem and deployed another version of the app, which is called Demo Music Store 2. The previous one was Demo Music Store, and there is a change in URL here, right? So essentially, he has already fixed this problem, deployed this app, and he sends me a note saying, you know what, as part of the resolution of the bug, you know what, I have fixed this bug. I fixed this performance issue. So the RPS should go up now. The requests per second should spike up, should go back to normal. Why don't you go validate that? Now, how do I really validate that this problem is fixed? So I need to go and run this load test again. And since I had done, let me go back to my load testing project. And open my load test here. Right, since I had parameterized that web server as part of all the web tests here, there is a very simple way, there is an easy way for me to say add context parameter, and here I put the name as web server 1 and replace this with the new URL. So what it does is now it lets me run the same load test against a different URL, and all the web tests and unit tests which are part of this test will actually pick up the new value of web server. This lets me quickly validate that I've fixed the problem, and it need not be necessarily the same app that I've deployed. It's in a different version with a different URL, right? So now when I hit run, again, another test is queued onto the service, and it is running on Azure, running on the load testing service out there. But this time, the requests will actually go to a different URL, which is the new URL here. Right? So once it moves into progress, we can actually see that the request per second actually goes up significantly here, and the problem has been fixed. Let's just give it a few seconds, and the moment we see that, all right. I think what I'm going to do is I'll come back to this and show you one that I'll not wait for a minute for this test to finish right here. Right. So the average value is now 59, now at 60. It's actually, this is the average request per second. It's gone up significantly. Here you can see this. This is the average request per second, and the problem is fixed. And therefore, I go say, hey, you know what? This performance problem has been resolved. Now, what did we see here? And what was different in this demo? This was my recap for my previous demo, which was running it on premises. And what happened? What was different here was the step number 0 to configure test environment just vanished. Right? You didn't have to spend any time to set up these test agents, to hook them up to the controller, and to do all of that stuff. It was automatically taken care of by you. So this way, the tests, the same tests which were authored on premises would run on the service as well. So you can quickly run the tests, analyze results, and you can get to the step of fixing performance and scale problems faster. And that's what we saw. And this is the real value. Right? All of these other steps, you have to do them to actually find and fix performance problems. So the whole idea is we have made it so simple for you to actually use it, so you don't have to spend any time setting up the environment, and you can get to the step that matters in the quickest possible way. Right? Okay, so we saw that. We saw how to set up this load test with a 200 concurrent virtual user load and run it on Azure, run it on the service really, really fast. But I can see what some of you are thinking. You know, that's not real world. Our applications are more complex than that. We require a lot more load. And the other thing is, the scenario I'm going to now talk you through is, hey, the music store app, yeah, and we've validated that the request per second is good and the response time is not dipping and all of that stuff. But next week, Eminem is doing his new music album launch, and there are going to be 50,000 users on my site as opposed to the normal 10,000, right, in a period of 4 hours. So how can I make sure that I'm ready for that? I need to scale up really fast. Let me show you how to do that. So I'll take the same load test here. Let me change the load pattern, and let me say, instead of 200, let's go up to 1,000 users. 1,000 concurrent users, right? And the other change I will do is, we have added this new property here that says, let me highlight that property for you. Which says agent count. This is the number of agents that you want to run this load test on when you run it against the service. So 0 is the default, which is automatic, which translates to 1 agent at the moment. Let me go and change this property to 4. So how about running this test on 4 agents with a user load of 1,000 users? Okay? So this is the exact same test. We are scaling it up. Let's hit the run button. Now what will happen is, when this test is queued on the service will provision 4 agents in the background, and distribute this test across those 4 agents. So each agent would get 250 virtual users. So it creates an overall load of 1,000 virtual users. And when the test starts, the service under test will actually see a much higher load of 1,000 virtual users. And thereby, the request per second has to go up. And if there were any scale problems, those should come up. And it started. So the test started working on with 4 agents as well. Yes, and we can see the counters here, the performance and the throughput counters coming. And as you can see, the request per second is now 314, and it's scaling up, which means my app is actually scaling up pretty well. In the last time we ran it, this was about 50. Right, and you can see that my user load to be at 1,000 currently, and all of the other parameters. And hence, this is how my test is scaling up. So initially, I talked about performance testing, load testing, and then stress testing. I did now that I've showed you the demos of how to do performance testing using Visual Studio both locally and using the service. Showed you a demo of load testing as well. Now, how about stress testing? So here is a scenario. Hey, that my marketing team for the music store online has told me that, you know what, in the next 12 months, we want to go global. And this means that we are going to go to Europe and Asia and Australia as well, and our user count is going to grow up 10x. Are we ready for that? What are the bottlenecks? From an engineering side, can you make sure that, hey, the app can scale when 1 million users access it instead of 50,000, right? So in order to do that, let me try to run a stress test here. I have the same test definition, and what I'll now do is instead of a constant load pattern, let me go change this to a step load pattern. And I want my maximum user count to be 20,000 concurrent users. So start from 1,000 users, go up to 20,000. And at each step, this is what I've done. Start from 1,000 users, go up to 20,000, and at each step increase 500 users, right? I want, because this is, I'm sure there will be problems in my app. It will not scale infinitely. But as I'm going up each step, I'm taking the ramping the load up so that I want to know where that bottleneck is. At what point my response time, my request per second starts falling down, and then I can go investigate the problems on the service at that particular time, right? So I do this. The other change I'll do is I'll change the agent count from 4 to 20. I think I'll need 20 agents to run this test. And I'll go ahead, click on the run button. Now this test is going to run as well. However, it will not be instantaneous. And let me tell you why. The service is dynamic and elastic. As in, if there are agents available for it to run your test would start immediately. But if there are no agents available which are free out there, because we can't run, our bill would be really high if we keep hundreds of agents free all the time. What it does is it provisions new agents on the fly, and that's the elastic part of it. So at this point, what is happening is I know that there are no 20 agents which are free. So it is going to spin up new agents. It's going to take about 5 minutes. I'll not wait. I'll come back to this at the end, and we'll see if this test started or not. Right? So basically what it will do is it will spin up new agents for you. Typically, this takes about 5 minutes, somewhere 5 to 6 minutes, under 10 minutes, and your test would actually start running after that. So you are not limited by the capacity of how much load you can generate. You could go as high as you want. What you are really limited is by how much your application can scale and when that will actually fall over, right? So we saw how to run a performance test and how to run a load test, and then how to run it on the service, and how simple it was to run your same test which was run on premises on the service. And then we also went and saw how we could actually scale up, and how the elastic nature of the service let you run the same test with as many agents as you wanted and take the load the overall load generated higher and higher. So that ends my second section, and in the final section, I want to talk a little bit about the architecture, some of the roadmap, early adopters, and next steps. Before that, are there any questions you had so far in the demo? Yes?
So you're testing a web app. What else can you test, like web services, unit tests? What's the things you would test?
That's a great question. So the question is, you showed testing a web app. What are the other things that you can test? So like I said, there are different categories of tests that we support. The web test, which I showed you, runs those tests at a HTTP layer, so it has to be requests and responses. If you have a website, you could go record it the way I showed it to you right now. And if you don't have a website, if you have like let's say a Windows 8 or a Windows Store app or a mobile app or something like that, or a rich client app, what you could do is you could run Fiddler and you could record all of these requests as part of Fiddler, then convert it back to a web test. That would work as well. If you had a web service, you could go straight away write a web test to test your web services. And if you had anything else, basically, you could run any unit test as part of it. I could write a blank unit test for all you care and put it in there. It will run as part of the load test. So unit test is your code, right? You could test different kinds of web services or whatever else that you have as part of your unit test. Are there any more questions? Yes? That's a great question. So the application that I showed was a simple application, the test that I showed here. What happens if there are complex applications when there is some kind of a state saved there? There are users and there are logins and the state written there. We handle all of those scenarios as well. If you look at when we talk about some of the customers, you will see that some of them have that application. So basically, you could have all of that data stored as part of a database or a CSV file, and then the tests can retrieve that. You can data bind these tests, and you can write a method to do the authentication piece and reuse it across tests as well. So we support those kind of authentications and these scenarios as well. Yes, there is enough MSD and documentation. I'll point you at the end of the session on how to do load tests, because this has been around for multiple releases in Visual Studio. How to do for some of these specific scenarios. We do have MSD and documentation for that.
If you were testing an on-premise app, is there any way to correlate server performance counters with the load test data?
Using a service?
Well, if you were using the service to do that.
That's right. So when I talk about roadmap, let me cover that point when I talk about it in the roadmap. We don't have it currently, but that's the number one thing on my list. Yes? Can you repeat that question again? No, if there is an issue with your client-side code, actually the web performance test that I showed you does not run your client-side code, does not run your JavaScript, for example. So if there are any issues as part of that one, you will actually not be able to figure out using this method. But there are ways to do that, and we can connect offline on how you can actually figure that out using Visual Studio tools. There are some customers who have specifically gone ahead and done that, some partners who have done that. Okay, so let me move to the final section. So I want to talk a little bit about architecture here and how does the service work, right? So we have Visual Studio, which is what you saw, which actually talks to a REST endpoint here, which is there there is a web service out here, which I have called the load test web service. This is part of the Team Foundation service, and this exposes a REST endpoint, a set of endpoints which Visual Studio talks to upload test, to query results, and to download results and all of that stuff. And behind the scenes, when Visual Studio submits a load test request to this web service, there is a worker role out there which orchestrates the entire stuff. It breaks the load test into slices, and this worker role is also stateless, and there are multiple instances of that at any point of time, and across an upgrade or if one of them goes down, the other one comes up, and we have all of that stuff there. This is the one which orchestrates the agent health, the kind of load test progress, and breaks it up into slices. And here is a pool of agents. right? And this is a dynamic and an elastic pool. Let's say my second load test that I ran required 4 agents. So when that is figured out, 4 agents get allotted for this load run, and they all run this load test independently. These are all worker roles. So they run this load test independently, and they write results into the store independently, right? So this is what they do, and once the load test is completed, these are released back into the pool, and we don't share these agents across tenants. They're recycled after each test in that sense. And then we have the other tables and blobs where the results are archived and they are stored there for so that they are persisted there, and you could download it at any point of time after your test is completed. So what's the point of this, right? Why? What I want to show here is, hey, we have not taken the existing on-premise controller agent and just ported that to the cloud, because we tried doing that in the beginning and there were problems. There were scalability and reliability issues, because although the architecture we have is a good architecture for on-premises, when we put it onto the cloud, the controller became a single point of failure, so that if the controller VM went away, your load test was just lost. And then the controller was a bottleneck, because all agents would actually write results into the controller, and that kind of became a bottleneck for scaling out. So what we have done is we have completely re-architected this, made it a true cloud-based architecture, and scale and reliability are the key aspects which we have kept in mind here. So that way, each agent runs its test piece independently, and it writes here, and all these other entities, all the entities in the system are stateless, right? And the next thing I want to talk about is about early adopters. So what has happened with the service so far before we put it out, before this date? What we did is in last October, September or October last year, we put out an early version of the service out there. The early version of the service did not have the UI, the polished UI that I'm showing you right now. It was just a bare bones service where you could submit some tests and we could download some results, and you would not get any counters in progress. We put it out there, and we asked internal teams to go, hey, use it and see if this is actually useful for your day-to-day load testing. Our idea was to make sure whether the service we put out, will it be really useful in real-world conditions or not. And I'm happy to tell you that 12 internal teams have been using it regularly for their sign-off for the last 7 months. And some of the big, I want to call out 2 teams there. One is the Team Foundation service team itself. So every sprint, when a new update of, every 3 weeks, when a new sprintly update of Team Foundation service is deployed onto Azure, it is tested. They use the load testing service here to actually test out and sign off. And that's the sign-off criteria. And it's not just done on a sprintly basis, but on a weekly and a daily basis too, they have a constant set of tests running. And there are a few teams within Skype as well, which is again a scalable service, which are using the load testing service. And the good part is these 12 internal teams have found it useful throughout this period to actually use the service for their real-world apps and use it as a sign-off criteria. And some of the things that we have learned, we have done this kind of a customer-driven development. So one of the questions that came up was, why don't you have service-side counters? We could have gone ahead and built that before the preview. But what we have learned from this usage is that what really matters is scalability and reliability. If that is not good, the service is not usable. So we have used the feedback that came from these teams to prioritize the backlog and work on those aspects first, right? And what we have also done, hey, the internal usage is fine, but how about external customers? How about people who are not completely on the Microsoft stack or doing ways we do it internally at Microsoft? So last month, we offered the early client bits, which I'm using here, to 10 external MVPs. And all 10 of them have tried it out. They've given us feedback that, hey, here are the minor issues. You need to go fix them. We have fixed some of them. But overall, that it is usable. And 6 of them have actually used it on either their real-world app or their customer's app as well, and done one load test and given us that feedback. The one external customer that I want to call out, and this was a special engagement we did. This was like about 6-7 months back. Florida state elections. Obama's elections, when it happened, last year's presidential elections, Florida state is the famous state from the previous elections. So basically what their CIO did, and this was in 2011, mid-2011 to 2012, they rebuilt their the voter registration app using Azure. and towards the end, before they actually did the final, before the elections, in order to do a final validation and load testing as part of that, hey, they used the service that we offered them through Microsoft Services, right? They helped them out in actually doing this load test. They used this service as well, and they were successful. So throughout this engagement, all these customers, internal as well as external, have figured out many problems in their apps, their services, fixed them, figured out few of the problems with their dependent services or with the Azure Fabric or SQL Azure as well, and a bunch of problems on our service as well. But with all of this done, today I am confident that when we put out this preview, this service will be usable by you, and you could actually go use it on your real-world apps, on your apps or your customers' apps, and you will actually find it pretty useful. And of course, it's not that we have learned all that is to learn. There is a lot more learning that we will have, and that will influence our backlog going forward. That brings me to the next segment, which is a roadmap. Hey, when we are putting this service out there for preview, what is it that is on the top of our backlog that we know that we are definitely going to work on in the coming months? And again, the previous slide, all of these customer engagements, and we have demoed it at various other internal forums as well as some NDA forums as well. And all of that feedback is factored into this backlog. So far, as one gentleman already asked, the top item here is to collect performance counters from service under test. Now we can do this on-prem, but on the service, we don't really do a good job. We don't really have this capability today to correlate the counters from your application under test, from your service under test, and from the client side on the same page. So this is that capability. It is absolutely possible for you today to collect your service, the counters from service under test, using a different tool, using New Relic or Ops Manager or some of the other tools with Azure or whatever else you are using, and correlate them manually, but this is doing that correlation kind of automatically. The second thing on our backlog is kind of richer analytics or reporting for the runs which are in progress. I showed you these two graphs of performance and throughput, but hey, how can I see more data? Can I see some more errors in the real-time view? Right? Can I drill down before my test actually finishes so that I can spot problems early on and stop the test if needed? This is that kind of a thing. Third one is scheduling of load tests. Today you hit the run button, the load tests run. Can I schedule it to run at 2 a.m. when I'm not there? Yeah, it's possible to do it today if you program against our client APIs. That's not the easiest or the best way to do it. So we want to build some kind of scheduling. And finally, my customers come from different parts of the world. So to simulate a true real-world pattern, I would want to simulate it from various data centers at the same time, or run it from a given data center. We don't support that today, but that's also on our backlog. So this, from a terms of roadmap, and again, since it's all, so most of these items are straight away from are in the service. And anyway, we have moved to a cadence where we deliver client updates on a regular basis as well. All of this value will be delivered on a continuous basis, right? So it's not that you have to wait for the next year or for the next release to get these. And the other part is, this is from whatever we have learned now. Since we are doing a customer-driven development, when we put out the preview, all of you will use it, the rest of the world will use it, and we'll hear a lot more feedback. And if some other thing comes up, and that is very important, that will move up the list so that we'll work on that one before this. Okay? So what are the next steps? So in terms of next steps, as Brian Harry already announced earlier today at the keynote and at the foundational session, the Visual Studio 2013 preview will be available to all of you at the Build conference on 6/26. And the load testing service is already enabled on the Team Foundation service, but you can't still access it because you don't have the client. So the moment you get that client, you will be able to try out the scenarios. We will have some more blog posts and some more documentation that helps you get started to do whatever I just showed you how to do it today. Please try using it, see if it is useful for you, give us feedback. Provide us feedback if it is both good or if it didn't work for you, tell us why didn't it work for you. Right? So the next question is around limits. Obviously, in June, we are going for a preview, and this means that we are not charging for it. It's free to use, right? But since it's free to use, and we didn't want to do an invitation code or a restricted access, so it's free to use for all TFS accounts that are out there. However, we don't have infinite resources as well. Of course, Brad promised to give away an Aston Martin, but that doesn't mean we have infinite set of resources to do that. So we will have to put some limits on usage. So by default, every user, every account out there will be able to try out load testing. They'll be able to do a single agent load test, right? And there will be some limits on how much usage you can do per month as well, and it will be refreshed every month in terms of virtual user minutes, right? So basically, we'll have a cap there, and you can that will be sufficient for trying out. But in case that is not sufficient for you for your real world usage, or if you want to increase that limit, we will actually have an early adopter program which you could join. If you join the early adopter program during the preview period, you'll get more usage and you'll get to work more closely with the product team. In return, we will get some feedback from you, and we'll get some in-depth feedback which will help us improve the service. Okay? So before I close, I just want to show you that the 20 agent test that I had run has completed, and I could go download that report. And if I say view report, this one tells me here the agents counter. Okay, here I'm going, let me bring this up. Oh, it had to happen sometime, isn't it? Let me try to go and open that report again. Since I am connected to the service, I need not be bothered about losing my work. This is my last test. And when I say view report, here, this is telling me that, hey, it's actually run on these many agents. Oops. Sorry about that. It's actually run on 10 agents, and these are 10 medium-sized agents. So essentially, we have allotted 20 cores for this test. It has actually run using 20 cores. And I can go ahead and see my performance characteristics, see my throughput. And if you see, notice another thing, that there are some 232 errors at this time. And if I click on those errors, and here is a validation rule, it says that the expected response was not achieved. And I can actually go here and see what was my test log, what exactly failed. And I can see that, I click on that, I see that, hey, you know what, at this point, at this step failed because my shopping cart did not load. And it was expected, since I had 20,000 virtual users, my app would actually fail, and I get some errors. And at this point, I know my failure point, and I can actually go and debug them, right? So I wanted to just show you that the test finished. So that brings me to the end of the presentation. And before I close, I want to do a recap. The way we started with was with these top challenges with load testing today. Setting up of machines was painful and slow. The cost for doing load testing was high, and there were some challenges if your app was hosted in Azure. Right? And with the load testing service going forward, these are no more challenges, because provisioning and setting up of machines, you don't have to do it anymore. We just saw how you could provision from 1 to 4 to 20, or if your app could scale, you could go even higher. Right? It was super easy, and it was quick to do that. And the cost, you don't have to acquire this hardware or keep it running on a persistent basis, so you pay only for your usage. Currently in the preview, it's free, but whenever we do enable billing, you will have to pay only based on your usage. And finally, if your app is hosted in Azure or on a cloud, it doesn't matter, because you're not running the test from your own premises. It's not bottled by the bandwidth or the firewall restrictions that you have here. The load is actually generated from Azure, and it just works. And the 12 internal customers that I showed you, and the Florida state elections, and all of these apps were hosted on Azure. And we have validated that the load testing solution that we have just works. So that brings me to the end, and I have about 10 minutes left for Q&A. But before we stop on this slide, if you have more questions, I would be around, or if you wanted to do a demo, or if you wanted to really try out if this would work for your site, if you wanted to create a quick web test for your application and try it out, you're welcome to do that. I will be at the product demonstration or the Visual Studio booth. I think it's called Developer Zone or something in the expo halls. I'll be there pretty much all the time, especially during lunchtime tomorrow and day after. Here is my email. And there are some resources over here where you could go and learn more. Of course, MSDN is a good place. Since load testing as a capability has been around for multiple releases, there's some good documentation on MSDN as well, and we are improving that for the service. Yeah, you all know this. You get started with Windows Azure, create an app, publish it, and you could win this Aston Martin. And the final thing is evaluate. So you can get this RFID tag. You could scan it here or outside the session room as well. Just go to the website, send an evaluation, give me feedback about what you felt about this session. And I take feedback from you very seriously. It's an important process for me to improve upon or know how well I did. With that, I'll leave this slide and open it up for questions. I have my cards over here if you wanted to get in touch with me with my contact info. And I will be, post this session, I'll be available at the booth as well. So thank you again for making it to this session, and I'll open it up for Q&A.
Do you have any scenarios for on-premise applications?
The question is, do I have any scenarios for on-premise applications? So if you have an on-premise application and you can open up the endpoint publicly, it will just work. Because we don't make any assumption that your app is Azure hosted, because we just test a public endpoint. So we have also, there are a few external customers, MVPs, who have tested it out and tried that it works. And one specific thing I want to call out, since you asked about on-premise application, there were at least 2 customers who came back and told us, you know what, I have an on-premise application. I can't really open up the public endpoint. So what we did is we provided them the range of IPs of the load generators, which is provided by Azure, and they did an IP filtering to only allow traffic from that IPs through the firewall, and that is how they made it work.
So basically, once you connect everything from Azure in, however, it's the virtual networks or whatever, once you get that connectivity in,
That's right. Yes. Yes, sir.
Once you actually stress the application to it, or how do you actually determine what areas of the app need to be fixed? Let's say you didn't like the application, you're a third party. What are some strategies to go in and help figure out
That's
problems here and there?
That's a great question. So once you figure out that the application, once you run a stress test and make sure that, and determine this is my breaking point, how do you really go after the problems, right? So in order to do that, let's see if I can do this demo. What you would have to do is, hey, this tells you a great point of what was the exact time in which these failures occurred, and it gives you the errors on the client side as well, which will give you some hints. But if you want to really go debug it to the next level, what you would have to do is you'd have to look at the right service, right counters from your service under test. Right? In this case, I have actually set up a let me try to bring that up, and let me try to get some historical data for the last 30 minutes as well. So what this is doing is it's fetching the Azure counters, the counters that I have configured in my Windows Azure Diagnostics from my application under test, and it is showing what are the counters for me, right? Depending on your app. So I have requests per second here, and you could measure some specific things. You could create custom counters and measure specific things such as, hey, these are my DB writes, these are my DB read operations. What is it that I want to monitor? And as I can see, there are 2 spikes here, and I could actually go and see which is this value that is picking up. Is it my CPU memory? Is it my request per second? Is it like what is the thing that is actually hitting the limit? And then you would actually figure out, get some hints as to where the problem is from there.
you said the initial free trial was for 1 agent. About how many virtual users can an agent generate?
So we'll have 2 limits. Okay, so your question is how many agents, how many virtual users will one agent generate? Well, that depends on the type of your test and the type of your app. If you have a very simple web test like I had, we have even had web tests where it could go up to 1,000 concurrent virtual users. But there are some users who write unit tests, which are heavy in nature. I'll give you an example. Team Foundation service has different kinds of tests. They do tests for their homepage, and an agent could generate a significant hundreds of virtual users. And they do some tests for their source control system, which is checking in and checking out code. And there, they only get about, like, I think, 40 or 50 virtual users, because these are pretty heavy operations. They are disk IO intensive operations, right? So it actually depends on the type of the app and how heavy your tests are. There is no golden formula for that. In future, we would want to do some things to move into a direction that, hey, can we suggest you, or can we automatically predict the number of agents that your test would need given the virtual users? But today you will have to set it yourself, and it depends. A typical web test would actually be somewhere between 250 to 1,000. All right, so if there are no further questions, I would want to thank you again for your time, for choosing to come here in this session. Please do fill out the evaluations, give me feedback, and if you have any further questions, I would be happy to answer them offline. Thank you.